Hello and welcome back to our channel. And today we have brought to you a very special topic that is called as solar power or solar energy. So, as the name suggests, solar form of energy is the energy that converts the sunlight into an electricity. So, as we see in nature, we've got the sun and we have abundant sunlight and researchers and the scientists have found a way to harness that energy, which is a sun energy, into an electricity which can supply power to all the gadgets that we use and all the appliances that we have around us. So, how the solar energy is produced, that is hidden in the fact of the effect from the physics called as photovoltaic effect. So this is basically an effect that converts or transforms sunlight into an electricity. We will explore detail the physics behind it as we progress in this model. So as you can see that on the rooftop of a residential area, you will often always find such rooftop panels, which are called as solar panels. Okay. So solar is also used to power a simple handheld equipment or gadgets such as your calculator or your wristwatch. Inside the power to run these gadgets coming from the solar cell, which is inside these equipments. And to the large level, you can have a rooftop of your house entirely covered with such solar panels, or you can have a complete solar power plant to supply the energy needs of the industry by means of solar techniques or solar energy. So there are few facts that we need to understand where the solar energy progress lies currently. So in 2023, it is reported that the solar energy generated 5% of the world's electricity. So you can imagine it's the percentage is still only 5%. However, in 2015, it was only 1%. So it is a use of solar power to generate an electricity is rising day by day, and it is increasing. So there are application, as I said, you can have your calculator, wristwatch, etc. Now let us understand and go to the basics of the solar power, the cell, which is responsible to generate the sunlight into an electricity. So this unit is called as photovoltaic cell or a solar cell. It is basically made of crystalline silicon. And the fact is, as of 2022, over 90% of the solar market is made of crystalline silicon. So when you talk about solar cell, its basic unit is crystalline silicon. Now there are two types of crystalline silicon. Here in this picture to the right, you've got the crystalline silicon solar cell, which is made of monosilicon. That is the simple and single silicon piece. And here on the left, you've got the crystalline silicon solar cell, which is made of polysilicon. So this is monosilicon material, this is polysilicon material. Okay. So this solar cell, or in other words, called as photovoltaic cell, as I said, photo stands for light and voltaic stands for it produces the voltage out of light. So this PV cell in short form or solar cell produces a fluctuating DC power as per the sun's radiation. So when sunlight falls on the top of the surface, it produces the fluctuating DC power. Why we are calling it fluctuating? Because the sunlight and the sun rays, they are also not the same in the intensity. For example, in the morning, you will have some uh, radiation power of the sunlight. In the afternoon, that power of radiation will intensify. In the evening, it will drop again. And in the night, it is negligible, right? So in such situation, you say that as the radiation power incident on the surface of this PV cell is varying, therefore the DC voltage that it will produce will also vary. Now, how to use that generated DC power to power the all appliances and the gadgets that we use in our homes, in our offices, in our industries, and in our wearable devices such as wristwatch, smartphones, etc. So the inverter is the device that is used to convert the DC into the AC. So before I explain you the full operation, let us have a look at this large array of solar panels. So you can see that this each square rectangle panel is called as solar panel, and each of these rectangle panels there is small squares. They are unit solar cells, as we see in our previous slide. And these large panels are connected in an array fashion. As you can see, this is panel number 1, panel 2, panel 3, 4, 5, and so on, to create a large array of such panels. Okay, but in the heart of it, you've got the single unit cell, as you can see this piece of square right here. So here, this is a typical system of solar power plant that is used to power our houses or our offices. How? We see that there are 4 panels that is placed on the rooftop of a house or office. So this is part number 1 of the entire system. Now, these solar panels, when they are incident or exposed to the sunlight, they produces the DC voltage. Now the inverter is used to convert that DC power into an AC power, and that AC power is given to the fuse box which is installed inside the office or the house, which then provides that AC power into to power the appliances and the gadgets and the equipments and the instruments such as television, refrigerator, fridge, mixer, and so on and so forth. You also can have option in terms of storing that AC power into the battery. So as you can see that there is a battery also. So when you don't have access to the sunlight, you can use the stored power in the battery to power and energize your devices. In another form, you can also say that when there is no enough sunlight, or in the case there is a night where there is no sunlight, you can use the grid power, which we use regularly as a regular power source to power our home appliances. So what you have here outside your house or office, you have a grid, power grid. From that, the power comes into your meter, and the meter is connected to the fuse box. Is the two-way transfer. Here is also two-way transfer. And then that AC power is being used for your residential and office needs. So this is the typical schematic representation of grid connected residential photovoltaic power system. Okay. So as I said, these multiple solar cells are connected inside these panels, and these panels are wired together to form an arrays. So here you can see that when you have a need of supplying a large electrical power or electricity to the industry needs, such as the plants, so you need basically a power station, such as thermal power station, the conventional power station we have seen already. So you can also have the photovoltaic power station. So as you can see that this is a picture of having large solar panels placed in an array fashion over the large land or geographical area. So as of 2018, the world's largest operating photovoltaic power station has surpassed to produce 1 gigawatt of solar energy. So this is the record that we have in place. So now such a large photovoltaic power station, they are able to reduce up to 1 gigawatts of even more of power in the form of solar energy. So what about the cost? As the capacity nowadays, the capacity in recent years, the capacity of producing the power through solar energy has exponentially increasing, and the cost is exponentially decreasing. For example, in 2021 in the United States, residential solar cost is set to fall from $2 to $4 per watt. So if you want to generate 1 watt of solar energy, you need to pay $2 to $4. And the utility solar cost, it means some equipment and installation and all that, that was around $1 per watt. So let us come back to the basics. So again, as I said, this is a unit photovoltaic cell. So basically, it's a material which is a silicon, and that is a semiconductor. Okay. And so when you talk about the semiconductor, this is basically single junction solar cell, which can produce maximum open circuit DC voltage of approximately 0.5 volt to 0.6 volt. I repeat again, this solar cell unit is a silicon semiconductor PN junction that is able to produce maximum open circuit voltage across its two electrodes, top and bottom, to be about 0.5 to 0.6 volts. The photovoltaic cells, as shown right here, may operate under sunlight or even artificial light. So, for example, you don't have natural lights in the form of the sun. You can use artificial light to fall on the surface of it to produce the DC voltage. So that's why we also call it as a they are also called as a sensor. So it means they are a transducer to detect the lights and convert that light in the form of electricity. How is the process? So they absorb the light on the surface and then they generate excitons, which are basically called as bound electron hole pairs. So those who know the semiconductor PN junction theory should be able to understand what I'm speaking about. Okay. And when those bound electron hole pairs, because of the incident light on the surface of this solar unit, are generated, the next step is to separation of the charge, those charge carriers, which is electrons and holes, and they are of opposite types. So that's why when they are separated, they produce this electrical voltage that is shown by means of this battery symbol. So light arrow indicates the incident light, and the positive and the negative are the charge carriers that is produced as a result of this process. Okay, and then you once you the separate extraction of those carriers is connected to an external circuit. Okay, now the output power of the solar cell is affected by many factors. For example, temperature, that is the weather, uh, material properties, how good your material is, and also the weather conditions such as temperature, humidity, and of course, how much is the solar irradiance, how much is the incident light on top of the solar unit cell. Now, uh, this is the typical PV system, photovoltaic energy production system. So you start with the solar cell, okay? And from cell, you make the panel. Not the panel. From solar cell, you make the solar module. So this solar modules is, let's say, few tens of centimeters in length and width. Okay. So in the solar model, you see that these solar cells, they are all placed in a series fashion. Okay. And then from solar module, you create the largest solar panel. So you see in this solar panel, you've got the four modules, 1, 2, 3, 4. And in solar module, you've got this solar cell, for example, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 4, 40 solar cells inside one solar module and four solar modules inside one solar panel. Once you have a solar panel, you create solar arrays in this fashion. So you see, you got the four solar panels, 1, 2, 3, 4, to create the solar arrays, and that makes up your photovoltaic system. Okay. So it also involves electricity meter, AC isolator, fuse box, inverter, battery. We've seen that in all these modules in the previous slides. Then you've got the charge controller, generation meter, DC isolator, cabling, mounting, and tracking system. So this all is the components or the blocks to make up the solar system or photovoltaic system. So now, photovoltaic modules, they often have a sheet of glass actually on the sun facing slide. So when you see this solar cell or module or panel, on top of it, you have a glass sheet where the sun is following. So that glass sheet allows the light to pass inside the material while protecting the semiconductor wafer. So this is basically a semiconductor silicon wafer. Okay, so when light falls on this material through the glass, The light can be allowed to go inside, but it cannot damage that wafer. That's the use of glass sheet. Okay. So solar cells are usually connected in series, creating additive voltage. So for example, this unit cell is producing 1 volt output. So that is placed here, and all such solar cells are connected in series. So the total voltage will be 1 plus 1 plus 1 plus 1 and up to all the units. So if there are 40 units and each of these cell is able to produce 1 volt DC, then total voltage produced in series, because they are connected in series, that will be 40 volts. Okay. Now, you can also connect those cells in parallel to create the higher current, because we know that the voltages in series adds up and currents in parallel adds up. So that's how you decide. But usually the solar cells are connected in series because you need a voltage. Okay. So as I said, solar cell is becoming cheaper. By 2020, the United States cost per watt for utility scale had declined to just under $1. So that's the magic of solar cell. So hope you like this video and found this information quite useful about how the solar power or solar energy works. You understood about the basic concepts of converting light into electricity. You understood what is solar cell, what is solar module, how the panels are created, how the photovoltaic system works inside our home if you have installed, and even we talked about the cost and the installation and the capacity of generating solar power. So if you like this video, click the like button, hit the subscribe button, share this video with others for a wider reach. Stay tuned for more engaging and informative content like this. Till then, wish you happy learning.